Okay, so our next unit is called factoring. And it's basically the reverse of multiplication of polynomials. So far we would have done, for example, if I had x plus 1, let's just say times 2. When we multiply them, that's going to equal 2x plus 2. So that's going this way is multiplying. This unit is going backwards, which is what we call factoring. And so today we're just going to start with just the introduction of it. We'll do it as straightforward as we can. This unit can be quite tricky if your multiplication tables aren't super strong. It's kind of similar to multiplying polynomials, just in that it's not conceptually it's hard, but you can make a lot of errors along the way. It's similar to that. This unit again is going to be a couple weeks long. We're going to do another investigation within this unit as well. Yes, that's all I have. Okay, so let's look at this first part. So expanding and factoring. Page 321, we're all good? Lovely. So let's go through. If I was to multiply the 2x times x plus 5, so this is review right now. Who can raise their hand and tell me what this first example is when we multiply it out? Oh, come on, guys. Graydon, lead us away. X. So this next one, we're going to do FOIL. So a binomial by a binomial forms a trinomial. So we get x squared plus 3x plus x plus 3, which gives us our final answer of x squared plus 4x plus 3. A second example here, so I get 2x plus 3 times x plus 4, so we get 2x squared plus 8x plus 3x plus 12, which gives us 2x squared plus 11x plus 12. I should have written that up here. And then lastly, this is the term where they're going to all cancel out. So we start off with an x squared plus 5x minus 5x minus 25. So those two middle terms cancels out, leaving me with an x squared minus 25. So our math language, in these ones we've expanded a product of polynomials to form a sum or difference of monomials. So that's fancy math language. Sum or difference is addition and subtraction, right? So we're adding different single terms together. In this unit, we're doing factoring, which is what I was talking about earlier. So we're going backwards in this. There's 3 different major types of factoring, and we will be learning all 3 of them. I think this next example is it's just rewriting these back in the way it was. So basically, I'm just going to write C above. So for example, in this one, this column is our factored form. This column is our expanded form. I'm not going to make you rewrite these out twice, though. Turn the page. So today we're going to be focusing on the greatest common factor and using that to start our factoring out with. Greatest common factor, what's the difference between what is a factor? Does anyone know? What are the factors of 6? Good, 2 and 3, right on. So that's what really comes into play and why I said earlier it's so important that you have strong multiplication tables for this unit. If your multiplication tables are really weak, I will gladly give you a times table. You can take that times table with you into our test if you want it. So they give the examples. We want to find the greatest common factor of 48 and 72. So when you do greatest common factor, I'm just trying to think of where's space for you guys. I'm going to just write this out to the side. See if you could fit it up at the top maybe, up here. But do you remember back in like grade 7 and 8, you would do factor trees. So from 48, I could say that breaks down to be 24 times 2. Do you remember doing this? And then 24 breaks into 6 times 4, 3 and 2, and 2 and 2. At the end of each of your factor trees, you stop with a prime number. Do you remember doing that? Good. So they've come up with their list here. So for 48, they wrote out 1, 2, 3, 4 2s. I also have 1, 2, 3, 4 2s in mine. Then they have their 3, and they did the same thing for 72. So when you're figuring out your greatest common factor between two numbers, you're going to see how many different common pieces there are between the two. So 48, we just counted, had 4 2s. 72 only has 3. So that means there are 3 2s common in both of them, as well as a 3. Only 1 3. So when we multiply that out, which is what they've done here, what do I get for an answer? Two times 2 is 4, times 2 is 8, times 3 is 24. So that means 24 is the largest number that goes into both 48 and 72. Where this comes into play, where this gets a little bit more difficult is then when we have variables, right? So that was the grade 9, grade 8 version of doing greatest common factor. Okay, now it's the greatest common factor between 6a cubed and 9a squared times b. So you're going to list them out again. So for 6a cubed, I only can break that down to a 2 and a 3. And then a times a times a is the only way I'm going to get an a to the power of 3. If I was to do this as a factor tree, I think it's easiest to kind of split it as a 6 and then your a cubed. The 6 is going to split into the 2 and the 3. To get an a cubed, I have to have 3 a's. For 9a squared b, same thing. So I have 9a squared b. 9 I only can break into a 3 and a 3. A, B. So now what's common between both of these? 1 3 is common. The 6a cubed doesn't have another 3, so that's why we can't use 2 3s. Then 2 a's are common in both of them as well. So on this one, I'm going to fill this in with a 3 and a, so our greatest common factor is 3a squared. So example 1, write the prime factorization of 8x squared y squared and 20xy cubed to determine the greatest common factor of the two. So you can do this in a lot of different ways. You could do it just as the list or using factor trees. I personally think the factor trees are the easiest. A question like this, I don't care about the process you use to figure it out. If your multiplication skills are awesome and you can just look at this and know what's the largest number going to go into both of them, you can just do that. So for example, I'm pretty confident we all should be able to do this one. What's the largest number that goes into 8 and 20? 4. Good, right? Like that one's pretty easy. 8 and 20 gives 4 as the largest value to go into both. When I say go into, it's divide equally. So it's like you get no decimals. So then between x squared y squared and xy cubed, 1x and 2y's are common. you guys remember that the 3 dots, so it's like therefore 4x, I wrote x squared is our GCF. Greatest common factor. So you could show your work like that. This question, fairly straightforward. If you just wrote 4xy squared, that would be sufficient. All of these questions in this lesson are going to be your level 1-2 questions, if that. We're going to get a little bit more into it, so some of these would be a little bit simpler than just 1-2 in that way. Like there'd be a little bit more added. But that's fine for that sort of thing. Does that question make sense? Go ahead, Khalil. Yes, yes, I will definitely pause, sorry. Really big point. So what they've written here in their notes is basically what I've said, but they also add this. If all of the monomials are negative, use a negative for your GCF. That's really important as well, especially later on this unit. If you can factor out, which is what we're doing with the greatest common factor, if you can factor out a negative, do so. It makes your life much easier. So on these ones, between, do you guys want to try this example on your own? No? Okay. 12 and 15. The biggest number that goes into both of those is what? Hello. 3. Good. Then I have a solo AB here. So the smallest numbers I'm going to have that go into both of those is just, sorry, I should have said variables, is just an A and a B. For B, the biggest number that goes into the 18 and negative 24. So only one of them is negative, so we're still going to use a positive greatest common factor. Biggest number that goes into both 18 and 24 is 6. So then I'm going to look at my variables. I have 4 x's here, but only 3 here. So 3 is the most number of x's that is common. This example, I have 2 y's and 5 y's, so 2 y's is the most that are common. This next example, I don't have any numbers other than 1, right? 1's the only one that's common in both of those, so I can write down a 1 if I want. I don't have to. I have 3 a's and then 1 a, so only 1 a is common. This term has, the second term has no b's, so I can't use a b as a common factor. Then I have 2 c's here. So my answer could be 1 ac squared or just ac squared. On D, so now I have 3 terms here. All 3 of these terms are negative. So my greatest common factor at the end of all of this is going to be a negative. Then I have 40, 20, and 10. What's the biggest number that divides equally into all 3 of those? 10. A's are common in all of them. What's the most number of A's that are common? 2. Good. So I get negative 10 a squared. The letter B is in all 3 terms. How many B's are common? 1. Good. When you're writing out variables, it's also good to know we generally do our variables in alphabetical order. So that's why I like AB, ABC, not BCA or anything like that. Okay, so now using that information, we actually can do something with it, okay? So all of this is just like setting the stage. Turn your page. So you can factor a polynomial by removing the greatest common factor. So for example, the one we just looked at earlier, if I have 8x squared y squared plus 20xy cubed, we already determined that our GCF here, 4xy squared, is our greatest common factor. So you can factor it out is the language we use and see what's left over. So when you do this, I don't like how they wrote this out, so I'm going to show you how I would do it. So a question would read like factor 8x squared y squared plus 20xy cubed. Miss Melton saying like x squares. That's getting in my head. So I know that my GCF is 4xy squared. So when I rewrite this, I'm going to write that down first and then a set of brackets. So when I factor out the 4xy squared for my first term here, what am I left with? Well, 8 divided by 4 is 2. In order to get an x squared from my original, and I took out an x, I'm left with an x. The y squared, we took that right out. My second term, my 20, if I go 20 divided by 4, I'm left with 5. And then my x, I factored out at the beginning, and I'm left with my y. So your check would be to multiply it back in. We are going to do these sort of things constantly for the next 2.5 weeks, 3 weeks. What's really frustrating about grade 10 is you never do anything with this. So next year in grade 11, you would then go and graph this. You, in grade 12, and once you start calculus, you'll then take the derivative of this. So a lot of factoring is like starting the groundwork for when the math gets harder and learns more. This is very much like a foundation. So if you think back to like, I know this is a big analogy, but in grade 1, you start reading by just learning that A says A. Do you ever say that anymore? No. This would be that equivalent, but the grade 10 version. So it's a little bit more difficult than just sounding out a letter, but we're starting a new groundwork of a new foundation for when it gets harder and harder and harder. So you're not really this year going to learn why we factor, which is really annoying. But grade 11 and 12, everything you do will include factoring. And will include steps like this. So let's go on to the next one. So here they're like, the question would read, so it says complete the factoring. So here's my original. In this spot out front is where we put our GCF. So the largest number that goes into both 21 and 14 is 7. We can check that because 7 times 3 gives us back our 21. 7 times 2 gives us back our 14. So that's the check to make sure we know what's going on. Is there anything common between an x and a y? No. So in this example, 7 is it for our GCF. Gets to be a little more complicated. I now have 3 terms. What number is common between 5, 15, and 5? 5. Good. So 5 comes out front. Are there any x's that are common? How many? 2. Beautiful. So again, your check is to multiply it back in. Okay, so these ones, they've given us some prompts, but not everything. So they tell us in this first example that 5a is our GCF. If I go 5a times a, that gives us our a squared. 5a times what gives us 25a squared. Good. So questions like this, I like to say, so like this is what you should be thinking, is 5a times something has to equal 25a. What is this something? Just going to be 5, right? Our a is already out front on the original 5a. So 5 times 5 gives us the 25. That a just kind of tags along. This next one, they tell us our greatest common factor is a 2. So 2 times what gives us 18p? So you could actually go through and do the algebra of this. So I would go to divide both sides by 2. I'm left with that unknown. 18 divided by 2 gives us 9p. So you also could do it that way, right? Multiplication and division, those are the opposites of each other. So you could just go and divide it. Sometimes when we get lots of variables in here, thinking of it as division can be a little bit tricky some ways too. Okay, so this next one for C, they told us that our GCF is negative 2m. I have to get back to negative mn, so I'm going to have a positive 2, because 2 times negative 2 gives us negative 4, and then just an n is going to tag along. To get to negative 6, I would need a positive 3 with an n. Okay, this last one is a little bit intimidating. So they tell us 9x is our GCF. So if I did this first term and I divide it by 9x, 18 divided by 9 gives me 2. X squared divided by x gives me an x. Y squared takes along. Second term, divide that by 9x. 45 divided by 9 gives me negative 5. I should have said negative 45 because that's the subtraction symbol. X divided by x, those cancel out. Y hangs out. Last term, 9x divided by 9x is what? 1. Good, not 0. So I would get plus 1. Okay, I'm going to give you a few minutes. I want you to try A, B, and C. So try A, B, and C on your own. I'm going to start, but if you're still going, you can just keep going. 20x minus 6, the biggest number that goes into both of those is just 2. So when I write my factored form, I'm going to factor out that 2, which leaves me with 10x minus 3. So going from like left to right, we would use the language factor, which is our new unit. Our previous unit that we're testing on Thursday now, going this way would say to expand it. Does that make sense how I say that? So it's just the language we're using, which is going to be a hint to tell you what to do. This next one, 16 and 4, largest number that goes into both of those is a 4. 4x is in the first term, 2 in the second, means there's 2 common in both of those. So in this example, this whole term is my greatest common factor, right? These two are the same. So my first term, if I go 16 divided by that GCF, I'm left with 4x squared. I pulled the whole term out, so I just say have a plus 1. That plus 1 you could think of as like a placeholder. Raise your hand if you're 2 for 2. Okay. This next one, a little bit trickier. There's a lot going on here. There's a lot more to think about. So between 10, 8, and 2, my largest common number is a 2. The most A's that are common between all 3 terms is a singular A. The most B's that are common is 2. So that's my GCF. I put a bracket. 10 divided by 2 is 5. A cubed divided by A leaves me 2 A's. My 2 B's I took right out of that first term. Second term, I'm going to have 4 with a B because I took that A right out. I factored it right out. My last term, the 2 I factored out, the A I factored out, leaving me with 2 B's. Anyone get that last one? Good. Anyone want to share the mistake they made on any of these 3? No? Okay. Okay, that's okay. D, 12, 6, and 15. What's the biggest number? 3. Good. What's how many P's is common in each one? 1. Good. So my GCF here is going to be 3p. So what do I have to multiply 3p by to get me to that 12p squared? So that's going to be, sorry, 12p cubed. So I'm going to get 4p squared. To get to 6p squared, I have to multiply it by 2 and a singular p. 3 times 5 gives me the 15, and my p takes along. Be careful, watch your signs. It's really easy to make a mistake without thinking about the signs. Okay, E is a doozy. So let's do it one letter at a time. Between 25, 20, and 30, largest common factor. 5, good. So you could think of this as I'm going to end up having this, right? At the end of the day, I have 3 terms initially, so I'm going to have 3 terms at the end. It could just be a 1, but I'm going to have that. My signs, I took out a positive, so my signs are going to stay the same. Doing it this way might help you kind of break it down piece by piece. So 25 divided by 5, I have to have a 5 here in my first term. 5 times 4 would bring us to our 20. And then 5 times 6 brings us to our 30. So now if I look at our x's, I have 1 here, 2 here, and 4 here. So a single x is all that's common. On our first term, we took out that single x, that's gone. On our second term, we're left with 1x. And on our last term, we're left with 3 x's. I have 2 y's, 4 y's, and 2 y's. So I can take out, I did not leave myself enough space. I can factor out 2 y's. So my first term, I factored those 2 out. I'm left just with a 5. My second term, I have 4. So I'm going to still have 2 left over. My last term, I took out the 2 y's. Z's, 3, 2, and 5. So 2 z's are common. First term, I'm left with a solo z. Second term, factor them both out. Last term, I still have 3. So you could break it down doing it like that as well. Lots of ways to do these ones, lots of different ways to think about it. That last one's really hard. That's a really hard GCF question. Okay, one more question and then we're done this. So this last one is a really good question because it's kind of like an application of your greatest common factor. So the surface area of a cone is given by this formula. So pi r squared plus pi rs. So r is our radius, s is your slant height, or your slant length, is that measurement there. So determine the surface area of the cone. I'm not going to make you do that. I don't think we need to actually plug it in. That's fine. Part 2 says write the formula for our area in factored form. So I'm going to fill this in my extra space up here. My formula is pi r squared plus pi rs. What is common in both terms? Well, literally in both terms, I've written a pi and an r. So we can then factor out a pi and a r. Remember, pi is just a number. We'll always use the pi symbol in grade 10, but it is just a number. So it's like we're factoring out a 3 from both of these. My first term, I'm still left with 1r. My second term, I'm left with an s. If we were actually to calculate the surface area, I would argue that this form is going to be easier. It's easier just to add two numbers together and then multiply them, I think. Truthfully, you could argue either way. It's going to be personal preference, I think, but that one could be easier, and that's what they're getting at here. Sometimes when you're doing math, it might be easier to use some factor forms options. And that's it for GCF. So these are the questions I would like you to do. That said, so our test is Thursday, October 1st now. You can do these questions now, or you could review now and do them on Tuesday's class. That's totally up to you. But basically, we're going to have whatever time we do have on Tuesday, plus the remainder of this class time. So you still have 40 minutes left in this class to be studying. I would suggest finishing these questions first, and then going and doing some studying after that.